Algebra 2 lesson 12-3. Determinants and inverses. This lesson will prepare you to use matrices to solve problems, including how to find the area of a triangle with vertices anywhere on the coordinate plane. Kind of handy little tool. A square matrix is a matrix with the same number of rows and columns. For example, a 2 by 2 is a square matrix and it has 2 rows and 2 columns. Then it could be a square matrix. It's a 3 by 3. For example, 2, 1, 0, 4, that's a square matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a square matrix because it's a 3 by 3. Then you can get a 4 by 4, 5 by 4, etc. The determinant of a square matrix is a real number, not an imaginary number, that can be computed from the elements according to a specific formula. We will learn how to do that today. A singular matrix is a matrix in which the determinant is 0. Okay? So, identity and multiplicative inverse matrices. For an n by n matrix, whether it's a 2 by 2, a 3 by 3, or a 4 by 4, the multiplicative identity matrix is an n by n matrix, I, or I to the n, with 1s along the main diagonal and 0s every place else. Which means in a 2 by 2 matrix, you have 1s here and 0s every place else, and a 3 by 3, you have 1s there. On a 4 by 4, you go all the way down to 1s, and everything else would have to be 0s, and so forth. So if A and B are square matrices, A, B minus B, A equals the identity matrix. Okay? Then B is the multiplicative inverse of A, written A to the negative first, which is the inverse matrix. Okay? It's not the negative matrix, it's called the inverse matrix. It's going to be a bit confusing until we start using it. Once we start using it, it'll make a bit of sense. All right, to determine whether two matrices are inverses, multiply them together both ways, A times B and B times A. If each product equals the identity, then they're inverses. For each of the following are A and B inverses. Okay? So we're going to do this the hard way. And eventually, before this lesson is over, I will walk you through how to do it the easy way on the calculator, whether or not you're going to understand me when I do it, and it may or may not work. Yeah, because it's really hard to see without being able to see it on the screen, and because we have two different types of calculators in this room, I might just have to walk you through it in class. All right, so our A and B inverses. So the first thing we have to do is we have to do A times B. Okay? So I'm going to do A times B the hard way. Okay? 1 times negative 4 plus 1 times 5, and then 5 times negative 4, and then plus 4 times 5. I did it weird. I normally go across. I don't know why I do it that way. And then 1 times 1 plus 1 times negative 1, and then 5 times 1 plus 4 times negative 1. Okay, so if we work this out, here we have negative 4 plus 5, negative 20 plus 20, 1 plus negative 1, and 5 plus negative 4. So we get, and we add these together, and we figure them all out. Okay, okay, we get 1, 0, 0, 1. So it works that direction. Now we have to check to see if it works. This would be A times B. This was A times B. This was that. Now we have to do B times A. We're looking at the problem here the same, but I'm not the same English. You're going to have to do this like this. I'll never make you do more than a 2 by 2. I'm going to be nice, so I won't make you do a 3 by 3 by hand. Okay, I might make you do one of them in your homework by hand, but I'm not going to make you do a 3 by 3 by hand. All right, so now B times A then would be, this was a little bit, sometimes it's easier for me to do B times A if I rewrite it. So I'm going to rewrite it. So it's going to be negative 4, 1, 5, negative 1, and then A was 1, 5, 4. It's just easier for me My brain being dyslexic, I kind of mess things up if I can't see them straight. So I'm going to do negative 4 times 1 plus 1 times 5. And I'm going to do negative 4 times 1 plus 1 times 4. And then you're going to do 5 times 1 plus negative 1 times 5. Oh, it's a big one here, I don't know why. And then you're going to do 5 times 1 plus negative 1 times 5. And then you multiply these together. I get negative 4 plus 5, 5 plus negative 5, and negative 4 plus 4, and 5 plus negative 4, which gives me 1, 0, 0, 1, which means since they both equal, this is B times A times B equals the identity matrix, B times A equals the identity matrix, so yes, these two are inverses of each other. Yay, we're inverses! Okay, now I'm going to try to walk you through how to put this second one on your calculator, depending on which calculator you have. I'll walk you through it first using the TI-84, and then I'll try to walk you through it using the TI-5. So on the TI-84, you have to find your matrix, which is right above your x to the negative 1. And the 84 is going to look to the inverse of x button. Underneath that, above that, you'll see matrix. It's in blue, so you have to hit the second, x to the negative first, and it's going to come up with names, map, edit. First thing we have to do is we have to edit it, because we have to tell the size of this. So scroll over until you hit edit, okay, and it's going to come up and hit enter. And whatever it was on, whether it was on a 3x3 or 1x1, nothing. Now we're going to have to give it the size. This is a 2x2 matrix, so put in 2x2. And then simply enter your matrix A, which is 3, 2, 5, 4. So hit 3, enter, 2, enter, 5, enter, 4, enter. Okay? And then hit second, quit to get out of that. That's matrix A. And go down to matrix again. So second, hit x to the negative first. Go over to edit, and scroll down to matrix B now. Otherwise, you're just going to write over at matrix A, which will be bad. So go to matrix B, and this is also going to be a 2x2. And you have to put it in, just like you see it. So you're going to put in 2, enter, negative 1, enter. Put in a parenthesis, negative 5 divided by 2, enter parenthesis, enter. Another parenthesis, 3 divided by 2. And then on that parenthesis, and now you have that matrix. So hit second, quit. So now we need to do what A times B is. So you're just going to do A times B, and you're going to do B times A. So simply all you're going to do is hit second matrix. You want A, so hit second matrix, and just number 1 is highlighted, so hit A, and put your multiplication symbol in, and hit second matrix. Scroll down to matrix B, hit B, and sure. So now your screen should look something like this. And when you multiply those together, you get 1, 0, 0, 1. That's your answer. Now you have to do it in the reverse order. If you matrix B times matrix A, so hit second, inverse of x, scroll down and hit matrix B first, then do this again. Second, or do the multiplication symbol first. You don't want to mess that up. Multiply by second matrix, hit A now. So now you should have something like this. When you enter those, you get 1, 0, 0, 1. So it is definitely an inverse matrix. Okay. Now, if you have the TI-Inspire, it's a little bit, a few more keystrokes until you get to know it really well. Once you get to know it really well, it's not as bad as you think it is. Okay. So we're going to want to find a matrix, and to do that, next to the 9 is a little button that looks like this. It's got all these little squares in it. On the left-hand side of that button. On the right-hand side of the button looks like a book. Looks like that. You want the left-hand side of that button. Okay, this is 3 and 5. And again, I will walk you through this in class in case you can't follow me, or you can Google it yourself to try to figure it out. Okay, so I'm going to, and it brings up another screen which gives you all kinds of different matrix sizes. So scroll over until you get the 2 by 2 matrix you want and hit enter. And then you're just going to put in your numbers. And you scroll back up to it and get my numbers. So I'm going to do 3, and I'm going to hit tab instead of enter because it's easier. Tab, 2, tab, 5, tab, 4. And then I need to multiply that by the other matrix. So I hit the multiplication key, then I'm going to hit the matrix key again, and I need a 2 by 3 matrix, so I'm going to enter. And then I'm going to enter my second matrix, which was 2, tab, -1, tab, 5 halves, again use your parentheses. And it was negative, so I need to enter that because I messed up. Negative 5 halves, and your parentheses, tab, parentheses, 3 halves. And then hit enter. And you should also come up with 1, 0, 0, 1. And to do it in the reverse order, you're going to have to do the same keystrokes. Go back to your little matrix, pull up the 2 by 2, put in the B matrix first, and then put in the A matrix. Okay, that's how to put a matrix into your calculator so you can multiply. Both calculators. The Inspire has a few more keystrokes to it at first, but in the end, it actually works out to be about the same. So both of these are inverse matrices. Okay, let's move on. Every square matrix with real number elements has a number associated with it, and this number is called the determinant. Okay, if I give you the matrix A, which is A, B, C, D, okay, you'll write determinant A. You write it as DETA. It's exactly how you write it right here. If you want to find the determinant of A, you write that. Okay? You read it as the determinant of A, and to evaluate the determinant of A, you're basically going to multiply A times D and subtract B times C. So in other words, multiply down here, multiply down that way, and subtract 2. Okay? Determinants of 2 by 2 and 3 by 3 matrices. Determinant of a 2 by 2 matrix is pretty easy. You're just going to multiply A times D and subtract multiplication times C from it. The determinant of a 3 by 3 matrix is fairly complex. Okay? You're going to multiply A1 times B2 times C3, and then B1 times C2 times A3, and then C1 times A2 times B3, and you're going to subtract A3 times B2 times C1 plus B3 times C2 times A1 plus C3 times A2 times B1. There's an easy way of doing this because there's a pattern. Please notice the pattern, and I'll show you the release. We'll show it at the same time. Notice the pattern. Okay? The variables are A times B and A times B and A times B. Okay, subscripts 1, 2, 2, 1, 4, 2, 2. For a 3 by 3, your variables are A, B, C, then B, C, A, then C, A, B, and then A, B, C, B, C, A, C, A, B. And your numbers are 1, 2, 3, 1, 2, 3, 1, 3, 1, 2, 1, 2, 3, 1, 3, 1. The easiest way to look at a 3 by 3 matrix, okay, if I have A1, B1, C1, A2, B2, C2, A3, B3, C2. All you have to do, rewrite the first 2 columns again. Write A1, B1, A2, C2, B3, A and B, not A and C. A2, B2, and then C, A3, B3 down. And then you're just going to multiply in a diagonal. Okay? So I'm going to multiply A1, B2, C3, B1, C2, A3, C1, A2, B3, and then I'm going to subtract. Okay? Notice how it went A, B, C, B, C, A, C, A, B. And then it went 1, 2, 3, 1, 2, 3, 1, 2, 3. Now we're going to do A, B, C. So we're going to do 3, 1. Okay, so now you're going to do this one, subtract this one, subtract that one. Not hard. Just go down and then up. Okay, it's a really neat trick. It's pretty easy to do. And you can multiply the determinant. And yes, you will have to find your determinant offhand. And yes, your calculators can find your determinants for you. So you will have to be able to do it both ways, by hand and using your calculator. And hopefully you'll be good at both of them. So let's evaluate the determinant of a matrix. So evaluating a 2 by 2, pretty easy. All I'm going to do, multiply this way, and subtract, and multiply that way. Okay? So, I have 4 times 2 minus 4 times 2. So 8 minus 8, which is 0. So the determinant of this number is 0. Okay, let's make it so the determinant is 0. This one would be 8 times 3 minus 2 times 7. That's 24. Minus 4 times 10. Finding a determinant of a 2 by 2 matrix is really, really simple. Finding the determinant of a 3 by 3 is slightly more complicated. So I'm going to rewrite this. 1, 2, 5, 0, 4, 8, 1. Remember what I said. I'm going to do this in its finger. I'm going to multiply down this way. Okay, so I'm going to do, okay, I'm going to do 1 times 4 times 3, which is 12. 1 times 4 times 3. No, that's 0 times 6 times 5. No, that's 3 times 2 times 1. Okay, that's 12 plus 0, leaving them 0, 0, plus negative 6. Okay, that's all one number. Then I'm going to do the up one. So let's use this color. Okay, so I'm going to go this way, and then this way, and this way. So then it would be, I'm leaving down here, 5 times 4 times 3 plus a negative 1 times 6 times 1 plus 3 times 2 times 0. So 11 times 4 is 20 times 3 is 60 plus 6 plus 0. Okay, so now we have 12 plus 0 plus negative 6, and we're going to subtract this. So essentially what I have is 12 plus negative 6, which is 6. 6 minus 60 minus 6 is 54, so 60 minus 54. So 6 minus 54 is negative 48, and that's the determinant of my 2 by 4 matrix. If you set it up right, it's not really, really hard. It is, yes, easier if you have your calculator to it, but you'd be amazed. I can pretty much find a determinant of a 3 by 3 about as fast as people can put it in their calculator. So when you get really good at it, it doesn't take you too long. All right, you can use determinants to find the area of polygons. Since all polygons can be divided into triangles, all you need to do is find a way to find the area of the triangle. So let's look at an area of a triangle. The area of a triangle with vertices x1, y1, x2, y2, and x3, y3. The area is half of the determinant of A, where A is x1, y1, x2, y2, x3, y3, and the last column is 1. So pay attention to that. Okay, so what is the area of the triangle with given vertices? 1, 2, negative 3, 0, 5, 0. Okay. First thing we have to do is we have to write the vertices of the triangle matrix form. Okay, that's not hard. 1, 3. Remember, it's 1. It's x1, y1, 1. x2, y2, 1. x3, y3, 1. So there we have it. There's the matrix. And we have to do half of the determinant of it. Okay? So you have the determinant of this particular matrix. So I need to do 1, 2, 3, 5, 3, 0, 0. Okay, so here I'm going to have 0 plus 15 plus 0. And I'm going to subtract from that. Zero. I don't know what to get out of 0. 0 plus 0 plus 9. So I basically have 15 minus a negative 9. 15 minus a negative 9 is 24. And half of that is 1/2 the determinant. Okay, so 24 divided by 2 is 12. Or you can use your calculator to find it. This will be 12 squared. And they're done by hand. Using the calculator, simply done. All you have to do is put the matrix in. So as you create your second matrix, go to edit. This is a 3 by 3. So I'm going to change it to a 3 by 3, and I'm going to put in 1, 3, 1, negative 3, 0, 1, 5, 0, 1. Always make sure you've got the matrix in properly. Okay? And then we need to find the determinant of it. So if I hit matrix, I need map. So scroll over to the map, and you'll notice the first thing it looks for is determinant. So hit determinant, and then say second matrix, and pull up matrix A. And it tells you the determinant is 24, and then divide it by 2. After that is 12. On the TI Inspire, let's see, finding a determinant. First of all, I have to find where the determinant is. So I will escape. I will go back to my menu. Options. I will go down to matrices, matrix and vector. And I will, oh look, if you go down to matrix and vector, scroll down to, all I did, I'm going to skip this good, hit your menu. Go down to number 7, which is matrices and vectors, and then push to the right. And you'll notice number 3 is determinant, so I'm going to hit enter. So I'm going to do determinants of, now pull up my matrix. I have to put in my 3 by 3 matrix. So I'll scroll over to a 3 by 3 matrix. Okay, 3 rows, 3 columns, that's going to be okay. That'll be okay. And then I'm going to put it in. 1 tab, 2 tab, 1 tab, negative 2 tab, 0 tab, 1 tab, 5 tab, 0 tab, 1 tab. And then hit enter. It tells you it's 24 divided by 2, you get 12. So there you have it. So now you can find your determinants using both of your calculators. And again, I'll walk you through that in class. Done. Okay, that's determinants. Now to find inverses. The determinant of a matrix can help you determine whether the matrix has an inverse, and if it exists, to find the inverse. The inverse of a 2 by 2 matrix. Find the inverse of the 2 by 2 matrix. If the determinant equals 0, then A is a singular matrix and it has no determinant. Excuse me, has no inverse. If the determinant is 0, a matrix has no inverse. Simplest way to find the inverse of a matrix. If the determinant is not 0, then the inverse of matrix A is 1 over the determinant of, notice what we did. We switched the matrix around a little bit. Instead of A, B, C, D, and here was your original matrix right here, A, B, C, D. Notice, okay, these two things switched positions, and these two numbers just became negative. That's all we did. Okay? So for a 2 by 2 matrix, find the determinant to find the inverse of a 2 by 2 matrix. And by the way, I will never ask you to find the inverse of a larger matrix than a 2 by 2. If you have to find the inverse of a 3 by 3 or larger, I will allow you to use your calculator for that. So let's take a look at this. Does the matrix have an inverse? And if so, what is it? Okay, so the first thing we have to do is we have to figure out what the determinant is. So I'm going to figure out the determinant of A here, which is going to be 4 times 2 minus 3 times 2. So 8 minus 6, which is equal to 2, so yes, it has a determinant. Okay. Okay. Since it has a determinant, it has an inverse. Excuse me, yes, it has a determinant. Obviously, the determinant is 2, it has an inverse. The inverse is 1 over the determinant times, we have to reverse these, so this becomes 2 here, this becomes 4 here. And then the second row here, these become negative, so negative 2, negative 3. It's all you have to do. Swap 2 and 4, and then change the numbers to the opposite. So now I have to multiply this out. Now this is scalar multiplication. So 1/2 of 2 is 1, 1/2 of negative 2 is negative 1, 1/2 of negative 3 is negative 3 halves. Yes, I want it in fraction form, not decimal form, and 1/2 of 4 is 2. So there's the inverse for the matrix that we have. So yes, it has an inverse, and that's what the inverse is. Okay, so my inverse matrix is right here. 1, negative 1, negative 3 halves 2. All right, let's take a look at B here. Let's see if B has an inverse. Okay, so 2 times negative 10 minus negative 4 times 5. So negative 20 minus negative 20. 0, no, inverse. Inverse whatsoever. Okay, so let's do the inverse of C. The letter C has an inverse. So 7 times 3 minus 5 times 4, so 21 minus 20, 1. 1, so yes, it has an inverse. So the inverse is 1 over 1 times 3 goes there, 7 goes there, this is negative 4, this is negative 5. Interchange these two, make the other two negative. So it's basically it stays the same. So the inverse is 3, negative 4, negative 5, 7. And then we'll find everything 5 and 1. So there's your inverse for that matrix. And of course, you could put that on your calculator to find the matrix just the same. All you do is put it in the calculator, go to your setting, and go to your math key, or in the TI Inspire, go to your action key, go on the matrices, and ask for the inverse. Okay? Or you can just do the x to the negative 1 key of that. Okay, it's probably a little easier. Okay, for the TI Inspire, I believe you can find the inverse. I don't know if it has an inverse. Oh, it looks like you just need to do the x to the negative. Which I find that button. I know I've seen it before somewhere. Now just put an x in there first, just easy. So you can just put in your on the TI Inspire. All you have to do is put in your matrix, which in my case would be 7, 4, 5, 3. So I'll put in 7, 4, 5, 3. 4, 5, 5, 5, 3. Yeah. Okay. Now I want the inverse of that, so I'm just going to take it to the negative first power. So all I did was get my little caret key, take it to the negative first, enter that, and I get 3, negative 4, negative 5, 7. So there you go. Very simple way to get your inverse. Okay. Now, let's use this for a real-life application. You might be saying, why do we have to learn matrices? Because matrices give you lots of real-life applications. Let's say you have this lovely credit card with you. Bank of your knowledge, not credit card. Account number is 4173 1234 9876 1357. How can you use the matrix multiplication and the coding matrix to encode the following credit card? Which means, what do they do to encode things so that when you run your credit card, nobody else can steal it? That's basically what this is talking about. Okay, so the first thing you're going to do is write the coding matrix. Okay? And the coding matrix that they want us to use, okay, they'll give you a coding matrix because the coding matrix is different for every single solitary transaction. It's a random number matrix, so they can't be duplicate. The coding matrix we're going to use is we're going to use the coding matrix 4, 8, negative 2, 4. So we're going to use this coding matrix to encode. Okay, so this is our matrix. Matrix C is our coding matrix 4, 8, negative 2, 4. It says write the credit card numbers in an information matrix with 2 equal rows. Okay, well it has 16 numbers, so 2 equal rows would be 8 numbers in each row. So I'm just going to put the first 8 numbers, 4, 1, 7, 3, 1, 2, 3, 4 in the first row, and 9, 8, 7, 6, 1, 3, 5, 7. So there's my matrix that's with my credit card. You're going to multiply the coding matrix C by the information matrix A. And here's where having a calculator is so much easier than doing this by hand. So I'm going to take 4, 8, 2, 4, and I'm going to multiply it by 4, 1, 7, 2, 1, 2, 3, 4, 9, 8, 7, 6, 1, 3, 5, 7. And since I am allowing you to use calculators, you need to show me these steps on paper so that I know what in the world you were doing. Okay, since I've showed you how to use it on your calculator, you can choose which calculator you're going to use. Okay, I'm going to use my Inspire because it happens to be handy with it. And it's still got power. I may have to charge it really soon. Okay, so I'm going to put in my 2 by 2 matrix first, which is 4, 8, negative 2, 4. Multiply that by, and put in the matrix, which this case, I have to put it in a big matrix. So I'm going to hit enter, and it's going to ask me number of rows, and I'm going to say 2, number of columns. No, it's not 2 rows, I have to backwards. Number of rows, 8. Just go up to 8. And the number of columns is 2. No, number of rows, I had it right the first time. I didn't want to do that. Number of rows is 2. The number of columns is 2. And then 8. And we put all those in. 4, 5, 7, 4, 9, 7, 6, 7, 3, 5, 7. And I multiply those together. I'm going to get the following numbers. 88, 68, 84, 60, 12, 32, 52, 72. That's first row. Second row, 28, 30, 14, 18, 2, 8, 14, 20. So for this particular transaction, that's the set of numbers that's going to go in for my credit number. This is now my coded account number, 88, 68, 84, 60, 12, 32, 52, 72, 28, 30, 14, 18, 2, 8, 14, 20. That's my new account number. A lot more digits. Okay? And then it says, how can you use the inverse of the coding matrix to recover the credit card number? All you have to do is multiply the coded information by the inverse of the coded matrix. So in other words, okay, if I wanted to get back to my original credit card number, I'm going to take the coding matrix, which was 4, 8, negative 2, 4. I'll take that, multiply by its inverse, and multiply that by my new 88, 68, 84, 60, 12, 32, 52, 72, and 28, oops, 30, sorry, the numbers in the 18, 2, 8, 14, 20, and that'll get me right back to my original credit card number. So that's the application that you would use to apply the matrices. So matrices have a lot of applications. You just don't see them a lot of times because they're running in the backgrounds of lots of things, running in the backgrounds of lots of calculations with bank formulas, running in the background in an awful lot of computer programs because that's how you move objects. You actually, and we'll do that in a few lessons from now. So matrices are very helpful if you understand how to use them.